Hello viewers on YouTube. In this video tutorial, we are going to consider binomial expansion through the use of binomial theorem. In our previous videos, we have been considering Pascal triangle as a method of expanding binomials, and we made it clear that Pascal triangle can only be used when the power of the binomial is a whole number. Now, this next concept we want to introduce, which is called the binomial theorem, it can be used to expand any binomial whose power is of any form. That is, either whole number, negative, or fraction. Regardless, this method will surely work. So the first thing you have to be familiar with is this theorem. So what says the binomial theorem? It says that for any binomial expansion, a plus b to the power of n, where n can be any number at this time around, it can be a negative number, it can be a fraction, it can be a whole number. Then the expansion would be equals to the summation from r equals 0 all the way to n, then n choose r, also called n combination r, multiplied by the first term within the parentheses, which is a in this case, raised to the power of n minus r, then multiplied by the last term, b, raised to the power of r. So while expanding, the summation would not be there anymore. This summation is just used to specify the formula to identify it. While expanding, you are just going to be adding the addition symbol, the sum symbol. So this is just the formula. Let's just try to put it into good use by considering some examples. So example number 1, consider the binomial x plus 2 to the power of 4. Though the index is a whole number in this case, you can always use your usual Pascal triangle. But since the main purpose of this video is to understand how to use the binomial theorem, and we'll be considering using the theorem. So it says that this expansion corresponds to the summation from r equals 0. Now, what is the value of n in this case? N is equal to 4. Then it will stop when n is equal to 4, or when r equals 4, to say, excuse me. Then multiply by n combination r. The first term here is x to the power of n minus r. Then the last term here is 2 to the power of r times 2 to the power of r. Now, before you begin, I will suggest you write out all the values of r. This will make it easy for you to always have a clean process. So what will be the value of r in this case? R will be equal to 0. It will start from 0, then it will end at where n is, or what n is. So r will be 0, 1, 2, 3, and 4. So these are the corresponding values of r. So it means as the value of r changes, then these values will be changing as well. As you can see, they all have r terms. So let's begin the expansion right away. So x plus 2 raised to the power 4 will now becomes, so the first one, when r is 0, okay, now with 4 combination 0, then multiply by x raised to the power of n is 4 minus 0, again multiply by 2 raised to the power 0, plus this plus that is coming now is for the summation, plus the next time when r is 1, we have 4 combination 1, to multiply by x to the power of n minus r, that's 4 minus 1, r is now 1 in this case, then multiply by 2 raised to the power r, which is 2 raised to the power 1 in this case, as r is equal to 1. Again, we have the plus symbol, alright, then when r is 2, we have 4 combination 2, multiply by x to the power of 4 minus 2, again multiply by r raised to 2 raised to the power r, which is 2 raised to the power 2 in this case. Then for the next term, we have plus, when r is 3, 4 combination 3, multiply by x to the power of 4 minus 3, again multiply by 2 to the power of 3. And for the last time, when r is 4, we have 4 combination 4, multiply by x to the power of 4 minus 4, then multiply by 2 to the power of 4. So this is simplification. The next thing is to simplify this forward. So right now, x plus 2 to the power of 4 will now become, so you have to understand what a combination is in excess. 4 combination 0. So what does it mean in excess? Here's what you need to know. n combination r is equal to n factorial divided by n minus r factorial multiplied by r factorial. So what exactly is a factorial? The factorial of any number means you start from that number and you begin multiplying all the numbers that comes before that number. You multiply with it until you reach 1. What are we saying next sense? Consider 4 factorial. It means we start from 4 and we begin multiplying all the number that comes before 4 until we reach 1. So that will be 3, 2, and 1. So that's what factorial means next sense. You start from that number and you begin multiplying all the number that comes before it until 1. Now, you know that n is the power already and r is the what? The values that is approaching n. So we can proceed on finding the factorial of all the other 4 values. So 4 combination 0, that will be 4 factorial divided by 4 minus 0 factorial, then multiplied by 0 factorial. Now there are some basic properties of factorial you need to understand. And what exactly it is? Let me just give you straightforward. It is important to understand that 0 factorial is indeed equals to 1. There's a proof for that, and I have it right here on YouTube in my channel. Feel free to check it out. I will leave the link in the description. Now we also have 1 factorial. The result is still 1. Now here's what you need to know. Any number n combination 0, the result will always be 1, regardless. These are like constant value you need to keep in mind. Also, any number combination 1, the result will always be that number. And finally, any number combination itself, the result will always be 1. Keep track of these 5 constant values, as you'll be using them while expanding binomials using Binomial Theorem. 0 factorial is 1, 1 factorial is 1, n combination 0, where n is any number, is 1, n combination 1, where n is any number, is n, and n combination n, where n is any number, is 1. Perfect. So we can proceed forward. So this clearly means that 4 combination 0 is just 1, and 4 combination 1 is just 4, and 4 combination 4 is just 1. So instead of doing all this, let us proceed forward. So now we said 4 combination 0 is 1, so we have 1 times x raised to power 4 minus 0 is 4, times 2 raised to power 0 is 1, plus 4 combination 1, we said is 4, so we have 4 times x to the power of 4 minus 1, it gives us 3, times 2 raised to power 1 gives us 2, plus, now let's do 4 combination 2. 4 combination 2 equals, so this is another way we can express the combination, equals 4 factorial divided by 4 minus 2 factorial times 2 factorial. That gives us 4 factorial divided by 2 factorial times 2 factorial. Excuse me. And if we simplify that, 4 factorial means 4 times 3 times 2 times 1 divided by 2 factorial means 2 times 1. Another 2 factorial means 2 times 1. 2 times 1 cancels out. 2 here 1, 2 here 2. 2 times 3 is 6. So that means 4 factorial is 6. Good. So now we are having 6 times x raised to the power of 4 minus 2 is 2. Then 2 to the power of 2 is 4. Perfect. For the third term, or the first term, we have 4 combination 3. So that will be 4 factorial divided by 4 minus 3 factorial times 3 factorial. So if we simplify forward, we have 4 factorial divided by 4 minus 3 is 1 factorial times 3 factorial. Now, 4 factorial, that will be 4 times 3 times 2, and so on. So instead of expressing it as 4 times 3 all the way to 1, let's write it as 4 times 3 factorial. This is the same. Divided by 3 factorial. This cancels and gives us 4. So that means 4 combination 3 is also 4. So we have plus 4 times x to the power of 4 minus 3 is 1 times 2 to the power of 3 is 8. Good. And for the last term, we said anything combined with itself is simply 1. So therefore, we have plus 1 times x to the power of 4 minus 4 is 0 times 2 to the power of 4, which is 16. Perfect. So right now, we can simplify forward. 1 times x raised to the power 4 times 1 gives us x raised to the power 4, plus 4 times x cubed times 2 gives us 8x cubed, plus 6 times x squared times 4. 6 times 4 gives us 24. We have 24x to the power of 2. Then plus 4 times 8 gives us 32. 32x. And finally, we have plus 16. So this is our answer to the expansion of x plus 2 raised to the power of 4 through the use of binomial theorem. On to example number 2. So the concept is straightforward. Okay, just try and use the values of r respectively. You start from 0, then all the way to whatever value of n is. To understand more better, let's consider some more examples. On to example number 2. Feel free to pause the video and figure it out yourself, just to practice. Then after that, you can unpause it and see if you've got it right. So let's consider 1 minus 3x all to the power of 6. So let's assume we have to find the first 5 terms of this expansion. Okay, how can we do that? So just like before, let's write the formula. We know that this will be equal to the summation from r equals 0. Since we have to find the first 5 terms, then it will be all the way to 6, but we just want to stop at the first 5 terms. Okay, so n is 6. Then we have n combination r, 6 combination r, multiplied by the first term here is 1. Okay, so that will be 1. Put it in a bracket, but sometimes it might have a coefficient or negative sign. So 1 raised to power 6 minus r, then again times the other one is minus 3x raised to the power of r. Okay, so this is the expansion. So let's begin. What will be the corresponding value of r? Keep in mind, r will be 0, 1, 2, 3, 4, 5. So let's find the first 5 terms. 1, 2, 3, 4, 5. Let's just stop when r is 4. So we stop when r is 4. Okay, so that gives us the first 5 terms. Okay, now let's begin. When r is 0, we have 6 combination 0. What am I writing? Division. Multiply by 1 raised to the power of 6 minus 0. Multiply by negative 3x to the power of 0. Plus, when r is 1, 6 combination 1. Multiply by 1 raised to the power of 6 minus 1. Multiply by negative 3x to the power of 1. When r is 2, we have 6 combination 2. Multiply by 1 raised to the power of 6 minus 2. Multiply by negative 3x to the power of 2. When r is 3, we have 6 combination 3. Multiply by 1 raised to the power of 6 minus 3. Multiply by negative 3x to the power of 3. And finally, when r is 4, we have 6 combination 4. Multiply by 1 raised to the power of 6 minus 4. And finally, multiply by 3x to the power of 4. So let's begin the simplification. So this results in 6 combination 0. Said anything combined with 0 gives us 1. So we have 1 times 6 minus 0 is 6. 1 raised to the power of 6 is still 1 times, we are considering the first term now. Negative 3x all raised to the power of 0 still gives us 1. So it means for the first term entirely, everything is 1. Plus 6 combination 1. We said anything combined with 1 is that thing. So that will be 6. Then multiply by 1. 6 minus 1 gives us 5. But it's 1 that is raised to the power of this 5. So it means the result will still be 5. Oh, sorry, 1. Then multiply by negative 3x raised to the power 1 gives us negative 3x. Let me put that within the parentheses. Okay. Plus 6 combination 2. Let's do that right away. So that will be 6 factorial divided by 6 minus 2 factorial multiplied by 2 factorial. And 6 factorial can be re-expressed as 6 times 5 times 4 factorial divided by 6 minus 2 factorial gives us 4 factorial times 2 factorial. So the 4 factorial can get rid of themselves. Since 2 factorial is just 2 times 1, the 2 can reduce the 6 to 3, and 3 times 5 can give us 15. So definitely 6 combination 2 is simply 15. So therefore we have plus 15 times 1 raised to power 6 minus 2 is 4, 1 raised to power 4 is still 1, times negative 3x all raised to power 2 gives us 9x squared. Amazing. So for the next term, 6 combination 3, since we are through with this one, I can get rid of it actually. Okay, good. So 6 combined with 3 is 6 factorial divided by 6 minus 3 factorial times 3 factorial. 6 factorial can be expressed as 6 times 5 times 4 times 3 factorial. And the difference between 6 minus 3, 6 and 3 is 3 factorial times 3 factorial. So the 3 factorial can reduce, and then we have the numerator to become 6 times 5 times 4. However, 3 factorial is 3 times 2, and 3 times 2 results in 6, which get rid of this 6 entirely. But left over is 5 times 4, which is 20. So therefore, we have 20 here, times 6 combined with 3 is 20. 1 raised to the power 6 minus 3 is still 1, times negative 3x all to the power of 3 gives us negative 27. Let me put up the parentheses. Negative 27x to the power of 3. Perfect. So moving on. So now for the last term, which is 6 combined with 4. So 6 combined with 4. Okay, I don't really know why I'm just writing fraction. 6 combined with 4 gives us 6 factorial divided by 6 minus 4 factorial multiplied by 4 factorial. That gives us 6 times 5 times 4 factorial divided by 6 minus 4 gives us 2 factorial, and we have 4 factorial. So these cancels out. 2 factorial in 6 gives us 3. 3 times 5 still gives us 15. So that means for the last term, which is the 5th term, we have 15 times 1 raised to the power 6 minus 4 is still 1, times negative 3x all to the power of 4 gives us 81 x to the power of 4. Perfect. So now at this point, we can just simplify to the least form. Okay, here, this equal sign, and we have 0. So let's multiply. 1 times 1 times 1 gives us 1. Okay, we are getting the expansion right away. 1 plus 6 times 1 times negative 3. That's negative 18x. Good. Plus 15 times 9x squared. So what would that be? I need to use my calculator for that to make it fast. So I got 135 x squared. So that's 135. 135 x squared plus 20 times 1 times negative 27. 20 times 1 times 27, right? Negative 27. So gives us the same result. So that's 540. So put in a bracket, minus 540 x to the power of 3. And for the last term, we have 15 times 1 times 81. 15 times 81, the one which gives us the result. That's just 1215 x to the power of 4. Perfect. So now the next thing is just to simplify this one more time to have our least value. Then we have 1. So plus times minus 81x or minus 18x, we have minus 18x plus 135x squared. So plus times minus 540 is minus 540 x to the power of 3. Then plus 1215 x to the power of 4. So this is the first 5 term of this expansion of the binomial. So that's how to easily make use of the binomial theorem to expand binomials with power of whole numbers. So if you want, you can expand it entirely. You still have like 2 terms left because you'll be having like 7 terms. The number of terms is n plus 1. Perfect. So let's consider a situation whereby the power is not a whole number, but instead a negative or a fraction. And in this case, how do you want to handle the expansion? So here's an example. Consider the expansion 1 plus 1 over 2 x raised to the power negative 2. So let's take, for instance, we want to find the first 5 terms of this expansion. Now here's what you need to know. When the index is negative or a fraction, you can't find the expansion to the end because the expansion will be infinite. So no matter what, you'll be required to find some number of terms. You might be required to find the first 5 terms, the first 3 terms, and so on. But never will they ask you to expand the binomial entirely because it will continue all the way to infinity. We can only expand binomials till the end if the power is a whole number. But once it's a negative or a fraction, then forget about that. So let's begin. So let's assume we want to find the first 5 terms of this expansion. That means the value of n is negative 2 and r would be 0, 1, 2, 3, 4. That gives us the first 5 terms. Okay, perfect. So now let's begin. The formula says that the summation from r equals 0 all the way to n will be multiplied by n choose r. Then the first one, that's 1 raised to the power n minus r, again multiplied by 1 over 2x raised to the power of r. So this is the formula we'll be using. I'm going to get rid of it so it won't occupy most of our space. So just have it copied down, writing units. Okay. So for the first term, that's when r is 0. So we have n is minus 2 combined with r, which is 0. Then multiply by the first term, 1 raised to the power minus 2 minus 1. Sorry, minus 0. R is 0. That's n minus r. Then again multiply by 1 over 2x raised to the power of 0 because r is 0. Plus, when r is 1, we have minus 2. Choose 1. Okay, that's another name for combination. It's a way of selecting, you understand? Something from instead of something. Then multiply by 1 raised to the power minus 2 minus 1. That's n minus r. Keep in mind, n is negative this amount, so that's why. Then multiply by 1 over 2 x raised to the power 1, r is 1. Plus the third term, r is 2, we have minus 2 choose 2 multiply by 1 raised to the power minus 2 minus 2, and finally multiply by 1 over 2x raised to the power 2. Okay, perfect. I can illustrate that. Let me try and shift it a little bit so you can see it properly. Oops, that won't make sense because we already, let's just work with that. Let's work with it. So for the next term, when r is 3, we have minus 2 choose 3, 1 raised to the power negative 2 minus 3, then multiply by 1 over 2x to the power of 3. And finally, for the last term, we have minus 2 choose 4, multiply by 1 raised to the power negative 2 negative 4, and finally multiply by 1 over 2x to the power of 4. So this is what we have to simplify. So let's begin our simplification. So minus 2 choose 0, anything combined with 0, we said the result will always be 1. So this gives us 1 times 1 raised to the power minus 2, since it is 1 that is raised to power any index, the result will still be 1. We can multiply by 1 over 2x raised to the power 0, which gives us 1. So it means this entire first term is nothing but 1. Now, on to the next term, which is the second term. Minus 2 choose 1. We said any number or anything that is combined with 1, the result gives us that thing back. So we have plus minus 2 times So 1 raised power minus 2 minus 1, that's 1 raised power minus 3, it still gives us 1, okay, because it's 1 that is the base. Then we move to 1 over 2x raised power 1. That still gives us 1 over 2x. Perfect. Plus the third term, minus 2 combined with 2. So this is where work starts. Okay, so how do we do this kind of combination? Here's what I expected to do. So you need to understand that minus 2 combined with 2, yes, it's still equal to minus 2 factorial divided by minus 2. Then don't forget it's n minus r factorial. So r is still minus 2, is still 2. So we have minus 2 factorial, then 2 factorial. Now we get the formula. N combination r is n factorial divided by n minus r factorial, r factorial. Okay. Now what we're considering doing in this case is that let's do this minus 2 factorial. What would that be? That gives us minus 2 factorial divided by minus 2 is 4 factorial, then multiplied by 2 factorial. You will now pay attention to the numerator. You understand? But for you to understand this properly, I need your full attention. So listen and listen to me closely right now. Do you agree that 4 factorial is the same thing as 4 times 3 factorial? I think we have been using that in some of our examples. Why? Because 4 factorial is the same thing as 4 times 3 times 2 times 1. However, 3 factorial is at the same time equal to 3 times 2 times 1. Now, instead of this, why can't we replace with this? So that is why 4 factorial can be this. In fact, 2 factorial is equal to what? 2 times 1. Then we can clearly say that 3 factorial is the same thing as 3 times 2 factorial. So instead of 2 times 1, we can put 2 factorial. So generally speaking, if you want to break down the factorial of a certain number, you can always turn it to the product of that number and the factorial of the number that comes before it. And this continues in that pattern. So that's what we want to do in this case. Now, not only that, we can also at the same time notice something. What do we notice? We notice that the factorial of any number starts from that number, then begins multiplying with the number that comes before it. But that number, we observe that is just one difference from the exact number. What are we saying makes sense? Can you listen that 4 factorial we said start from 4, but the next number that follows is 3, which is 4 minus 1. How do you get that? The number that follows is 3, which is 4 minus 1. Similarly, the next one that will follow 3 will be 2, which is 3 minus 1. It means these numbers, they tend to decrease with just a unit. So that's what we are going to be using in excess. So therefore, minus 2 factorial, we can clearly say that it is the same as minus 2 times minus 2 minus 1 factorial. Are we together? Just like me saying 4 factorial is the same as 4 times 4 minus 1 factorial. Because 4 minus 1 factorial give me 3 factorial. Perfect. So now, this becomes minus 2 times minus 2 minus 1 gives us minus 3 factorial. At the same time, we can still break this one too and have minus 3 factorial is the same as minus 3 times minus 3 minus 1 factorial, which becomes minus 3 times minus 4 factorial. Then you stop here. When will you know where to stop? You will stop when you realize that you have this already. Whatever you are seeing there that as negative, you have it already. If it's a fraction, whatever you're seeing there that as fraction, you have it already. Then you stop. You don't need to proceed more forward. As the main purpose why we are doing this is so as to be able to cancel it out. You understand? So now instead of negative 3 factorial, I will replace with minus 3 times minus 4 factorial. So eventually we can say that minus 2 factorial is equal to minus 2 times minus 3 times minus 4 factorial. So we're going to replace this entirely with this one and see what will happen. So now we have minus 2 times minus 3 times minus 4 factorial divided by 4 factorial times 2 factorial minus 4 factorial. Now minus 4 factorial cancels out. Left over is minus 2 times minus 3 minus 2 times minus 3 divided by 2 factorial. We said is 2 times 1. Then the 2 reduces this to minus 1. Minus 1 times minus 3 gives us 3. So that means minus 2 combined with 2 is simply 3. So that's what we need in Excel. So that's how to simplify the combination of negative values. So we are going to have plus 3 for the, what's it called, for the third term, times 1 raised power minus 2 minus 3 is still 1. Then times 1 over 2 x raised power 3. The 3 will affect 2 and it will affect this one too. So that becomes 1 over 8 x raised power 3. And for the last term, which is this one, okay, oh, we are multiplying this one. So, because we actually did this one, minus 2 combined with 2. So that will be 1 over 2 is x raised power 2. That will be 1 over 4 x squared. Amazing. Because 1 raised power minus 2 gives us 1. Now for the fourth term, we have plus. So let's do minus 2 combined with 3. What would that be? Since we are through with this one, we don't need this anymore. Can get rid of it. So we can have enough space. And I can just bring this ones upward a little bit. Alright. Perfect. So we want to evaluate minus 2 combined with 3. That becomes minus 2 factorial divided by minus 2 minus 3 factorial, which is n minus I factorial times 3 factorial. Now minus 2 factorial is the same thing as minus 2 times minus 3 times minus 4 times minus 5 factorial. So I don't need to put in the brackets. Minus 5 factorial. So the concept we used earlier, I've used it straightforward. Okay, minus 2 minus 3 gives us minus 5 factorial times 3 factorial. That's just 3 times 2 times 1. So minus 5 cancels out. 3 cancels minus 1. 2 reduces minus 2. So we have minus 2 times minus 1 times minus 2. That gives us minus 4. Minus 2 times minus 1 is 2. 2 times minus 2 is minus 4. So that means minus 2 combined with 3 is simply minus 4. So now we have plus, let me put that in the parentheses, minus 4 times 1 raised power minus 2 minus 3 is still 1. Then just do times 1 over 2 x raised power 3 is 1 over 8 x to the power of 3. Amazing. So for the last term now, we have plus minus 2 combined with 4. Minus 2 combined with 4. We need to do that again. Minus 2 combined with 4. Okay, I'm using yellow this around. This was minus 2 factorial divided by minus 2 minus 4 factorial. Then 4 factorial. That gives us minus 2 factorial is minus 2 times minus 3 times minus 4 times minus 5 times minus 6 factorial divided by minus 2 minus 4 factorial gives us minus 6 factorial. 4 factorial is 4 times 3 times 2 times 1. The minus 6 factorial cancels out. Then 4 cancels this, minus 1. 3 cancels this, minus 1. 2 cancels this, minus 1. So minus 1 times minus 1 is positive 1. Again times minus 1 is negative 1. Again times minus 5 is positive 5. So it means that minus 2 combined with 4 gives us positive 5. Perfect. So we have plus 5 times 5 times 1 raised power minus 6 is still 1. Just 1 over 2 x raised power 4. That will be 1 over 16 x to the power 4. And now we are almost there. Final answer in this case becomes 1 times 1 times 1 is 1 plus minus 2 reduces this, that is minus x. Okay, plus 3 times 1 over 4x, that's 3 over 4 x squared. Again, plus minus 4 times, minus 4 can reduce this to 2. So we can have minus 1 over 2 x to the power of 3. Okay, plus 5 times 1 over 16 x to the power of 4 gives us 5 over 16 x to the power of 4. and we need one more step away. So right now, final answer becomes 1 minus x plus 3 over 4x to the power of 2 minus 1 over 2x to the power of 3 plus 5 over 16x to the power of 4. And this gives us the answer to the expansion of the first 5 terms of this binomial. By now, you should have been getting used to how the binomial theorem is used to expand binomials, regardless of what the index is. Now, let's consider a situation whereby the index is a fraction as opposed to the negative. And in this case, what can we do? Like I said, the process is the same as that of the negative. It's just that you're dealing with fraction now, not negative. In fact, the factorial stuff is the same thing, but you will see next sense. Let's begin. So let's consider the binomial 1 minus 1 plus 3x all to the power of negative 1 over 2. Okay, I should give you a bonus. It should be a negative fraction. If it's a positive fraction, it will be a little bit straightforward compared to the negative fraction. So let's deal with negative fraction. So let's assume we want to find the first 5 terms of this expansion as well and see what would happen. So for the first 5 terms, I will be equal to 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's where we're going to stop. But n in this case is negative 1 over 2. Don't forget, if you're dealing with a multiple choice question, you don't need to write the formula. You understand? Just make sure you understand the formula. But if you're dealing with a written or theory part, make sure you always write the formula before you begin the expansion. So what says the formula? It says that the summation of this expansion becomes the sum from r equals 0 all the way to n, which is minus 1 over 2. Then n combination r, negative 1 over 2 combined with r. The first term here is 1. This is r, okay? So we have 1 raised to power n minus r, n minus r, which is negative 1 over 2 minus r, as r is going up. Then multiply by the last term, 3x to the power of r. So that's the formula. Have it copied down. Perfect. So now let's begin. So the first term will be negative 1 over 2 combined with 0 when r is 0. Then multiply by 1 raised to the power of n minus r. N is minus half. R is 0. Again, multiply by 3x to the power of r. Here r is 0. That's the first term. Second term, when r is 1, we have negative 1 over 2 combined with 1 multiplied by 1 raised to the power negative 1 over 2 minus 1. Okay. Then again, combine with 3x to the power of 1, since r is 1 this time around. And plus, the next term, when r is 2, we have negative 1 over 2 combined with 2 multiplied by 1 to the power of negative 1 over 2 minus 2, because r is 2 this time around, n minus r. Then again multiply by 3x to the power of 2. We are moving on all the way to the third term, or the fourth this time around. So for the first term, we have negative 1 over 2 combined with 3, as r is 3 in that case. Then multiply by 1 raised to the power 1 over negative 1 over 2 minus 3. Again multiply by 3x all to the power of 3. And we have the last term, when r is equal to 4, we have negative 1 over 2 combined with 4 multiplied by 1 raised to the power negative 1 over 2 minus 4 multiplied by 3x all to the power of 4. So this is the expansion. The next thing is to simplify it to the least form. So negative half combined with 0, which identity combined with 0 is simply 1. So for the first term, now be 1 entirely. We're out of speed. I need to move this bit forward. Okay. Sorry. Perfect. So negative 1 over 2 combined with 0 is just 1. So we have 1 times 1 raised to power negative 1 over 2 minus 0. As long as 1 is the base, 1 raised to power anything, regardless of what that power is, the result will still be 1. Okay? Then multiply by 3x raised to power 0 and 3 raised to power 0 is still 1. So the first term entirely, just like before, still gives us 1. Now on to the second term. Negative 1 combined with 1. Any number combined with 1 gives us back the number. So that gives us negative half back. Okay? Times 1 raised to power negative 1 over 2 times minus 1. It gives us 1. Then multiply by 3x raised to power 1 is simply 3x. Amazing. So this third term, we have negative half combined with 2. So this is where work begins. Let's try to simplify that. Minus half combined with 2 is equals to minus half factorial divided by minus half minus 2 factorial. R is 2, that's n minus r factorial, then 2 factorial. Now, you see, pay attention to the numerator. This becomes minus half factorial is the same thing as minus half times minus half minus 1 again times minus half minus 2 factorial. You agree with this, right? You know, by the time we subtract the first one, we got this one. Then we subtract the second one, it becomes minus 2. Let me try and break it in pieces. So we don't need this anymore. We can get rid of it. Oops, I think that was a mistake. Let's try and shift it over again. Okay, perfect. So I said I want to break this actually, okay, before we move forward. Now, minus half factorial, we clearly agree that it's the same thing as minus half multiplied by minus half minus 1 factorial. But what will be minus 1 minus half factorial? We said that will be that number which is minus 1 minus half, minus half minus 1, then multiply by the number minus 1 again, factorial. So that becomes minus half minus 1, then minus 1 factorial. So this becomes what? Where this one becomes minus half minus 2 factorial. So this becomes minus half minus 2 factorial. So that's how I got the minus half minus 2 factorial. Understand? And as you proceed forward, you keep on getting those values like that. So now we can try and cut out some values. Since negative half combined with 2 as now becomes, instead of negative half factorial, let's replace with this one. We now have negative 1 over 2 times negative half minus 1 times negative half minus 2 factorial divided by negative half minus 2 factorial times 2 factorial. Now negative half minus 2 factorial cancels out. Left over is minus half. So let's do minus 1 over 2 minus 1. So what would that be? Let me write that here. So minus 1 over 2. Minus 1 is the same thing as minus 2 over 2. LCM can be 2. Minus 1 minus 2 is minus 3. That is minus 3 over 2. So that gives us times negative 3 over 2. And divided by 2. So we multiply that, we got 3 over 4 multiplied by 1 over 2. That gives us 3 over 8. So that's negative half combined with 2. The result is simply 3 divided by 8. I hope you got that. So we can move on. You can see of this and this as well. So we have plus 3 over 8 multiplied by 1 raised to power negative half minus 2 is still 1. Just multiply by 3x squared. Let's do 3x squared. That will be 9x squared. That will be 9x squared. Perfect. So now on to the first term. Negative half combined with 3. So let's do that. Negative half combined with 3 is same thing as negative half factorial divided by negative half minus 3 factorial, then 3 factorial. So negative half factorial is the same thing as negative half multiplied by negative half minus 1 factorial, not factorial, we can just continue simplifying, multiplied by negative half minus 2 factorial. Again, we need one more, multiplied by negative half minus 3 factorial, then divided by negative half minus 3 factorial, multiplied by 3 factorial. So these cancels out. Left over is just this terms we need to simplify. So I'll get rid of this instead and use that spot. So now we have negative half times, so minus 1 over 2 minus 1. When we did it earlier in the previous example, we got negative 3 over 2. Okay, then let's do minus 1 over 2 minus 2. Minus 1 over 2. So minus 2 is the same thing as minus 4 over 2. LCM is 2, gives us minus 5 over 2. Okay, so now we can have multiplied by negative 5 over 2. And don't forget we still have 3 times 2, which is the factorial of 3. So now I can get rid of this again and set it to be equal. So we multiply all this. Negative 1 times negative 3 gives us positive 3. Again, times negative 5 gives us negative 15. Divided by 2 times 2 times 2 gives us 8. Then we have it to be divided by 3 times 2 is just 6. And this equals to negative 15 divided by 8 multiplied by 1 over 6. So 3 here 2, 3 here 5. Final answer becomes negative 5 over 16. So that is the combination of negative, half, and 3. Perfect. So we can get rid of that and replace, as we have been doing. So therefore we have plus. So since negative 5 over 16, let's put it in a bracket, just like before. So 3x to the power of 3 is 27x to the power of 3. So now on to the last time. So what exactly would be negative half combined with 4? So I would suggest you pause the video and figure this one out yourself. And after that, you can just unpause it and see if you have done the right thing. So let's begin. Negative half combined with 4 results in negative half factorial divided by negative half minus 4 factorial, okay, times 4 factorial. So negative half factorial can become minus half times minus half minus 1 times minus half minus 2 times minus half minus 3 times minus half minus 4 factorial. Then we have a division of negative half minus 4 factorial, again times 4 factorial. Now these can cancel out and then you can push it forward. So we can still set this to be equal. Now like with this is equal to negative half times negative 1 over 2 minus 1. Earlier we said it's negative 3 over 2. Similarly, negative 1 over 2 minus 2. Earlier we said it's negative 5 over 2. Now let's consider negative 1 over 2 minus 3. So let's write that within the spot. So negative half. So negative 3 is the same thing as negative 6 over 2. So this becomes negative 7 over 2 by the time we add them together. So we got it. Then we have times negative 7 over 2. Then we have it to be divided by 4 factorial, which is 4 times 3 times 2. So the next thing is just to simplify this compound fraction to get our answer in no time. So this becomes, let's multiply these two. Minus 1 times minus 3 is 3 times minus 5 is negative 15. Now negative 15 times negative 7, what would that be? Let me use my calculator for that. So 15 times 7, so I got 105. So we have 105 divided by, the negative has gone, becomes positive. 2 times 2 times 2 gives us 16. Then we have divided by 4 times 3 times 2, which results in 105 divided by 16 multiplied by 1 divided by 4 times 3 times 2. So let's try and get rid of some stuff right here. 3 can go in 105. How many places? So let me divide 105 divided by 3. We got 35. So we have 35 divided by, I think no other number can go. 4 times 2 is 16. So let's multiply. Sorry, 4 times 2 is 8. So we have 16 times 8 gives us 128. So we have 35 divided by 128 as the combination of negative half and 4. So now we can just write it down as we've been doing so far. So where should I write that? Okay, before I get to the video, let me write it first. So let me just put it on top. We later express it. So that's plus, I'm talking about the last time now, plus 35 over 128 multiplied by 3x to the power of 4. 3 to the power of 4 is 81, x to the power of 4. So that's it. Now all this can go. And then we have our final answer. 1 times 1 times 1 is 1, plus 1 over 2 times 3x gives us negative 3x over 2. You know, the minus is still there. Then plus 3 over 8 times 9x squared gives us 27 x squared divided by 8. Then plus negative 15 over 16 times 27. So that would be negative 5 times 27. So that results in negative 135. So put that in a bracket, minus 135 divided by 16. Then multiply by x to the power of 3. Then plus, last time, that's 35 over 8 times 81. 35 times 81. 35 times 81 gives us 2,835 divided by 128 x to the power of 4. So finally, we got our final answer as 1 plus, no more plus, but minus 3x over 2 plus 27x squared over 8, then minus 135x cubed divided by 16, then plus 2,835 divided by 128 x to the power of 4. So this is the first 5 terms of the expansion of the binomial 1 plus 3x all to the power of negative 1 over 2. So I hope you find this helpful and understandable, and I want to believe in one way or the other, by now you should be able to expand any binomial regardless of the index through the use of binomial theorem. Thanks for watching. See you in the next video. Bye for now. So this is your exercise. Feel free to share your solution via the comment section below. So consider expanding this binomial all the way to the first 5 terms. 1 minus 2x all to the power of negative 1 over 3, and 1 minus 1 over 3x all to the power of negative 4. Thanks for watching once again. Bye for now.